Hi students, today we are going to see some lecture video, okay? That is not the board question. Some topics we will cover from chapter number 1. The topics include electric charge, conservation of charge, Coulomb's force law, and force between multiple charges, superposition principle, and continuous charge distribution. Everything we will try to cover in this video. It may take a little extra time, but we will cover point by point. Okay. See, what is exactly electric charge? The property of a material by which it exerts or experiences electric and magnetic effect is called the electric charge. You know the types of charge, right? Positive, negative, like two type charges are there. And one example I'll tell you. Lightning in the sky during thunderstorms due to electric discharge. That is an example of charge flow. Okay. So, part by part we will see. It may take time, no problem, right? So, the first topic is electrostatics, like astrophysics, nuclear physics. This is also a branch of physics which deals with the study of charges at rest, that is static charges. Okay. Just have a look into the text. See, some properties, some important facts you want to know about the charge. First thing is, there are only two types of electric charge. You know it, yeah, positive and negative. Like charges repel and unlike charges attract each other. These two enough, more than enough to remember. So there are two types of charges, positive, negative, and like a magnet, like charges repel each other and opposite charges attract each other. One of the board question was there from this topic, that is conservation of charge area. So three properties we will see. One of the most of the time 1 mark question is there. First property is additivity of charges. What is this saying is total charge of a system will be equal to the sum of their charges. Okay, because electric charge is a scalar quantity. So the total charge of the system is obtained simply by adding the different charges algebraically. Okay, that is easy. Another one fact is charge is conserved. Do you remember the energy conservation law? It is like that actually. Charge cannot be either created or destroyed. So it can only be transferred from one body to another. Hence the total charge of the isolated system is always conserved. Exactly same as energy conservation law. See this image. Before rubbing each other, total charge is equal to 0. None of the body is charged. But after rubbing, see the glass got positive charge, silk got negative charge. That is transferred. But total remains same, plus Q minus Q is equal to 0. Quantization of charge, useful for other derivation. What is quantization saying is, total charge will be always the integral multiple of numbers. That means charge does not exist in half, quarter, decimals, etc. Charge will be always like a charge of an electron multiple, 1e, 2e, 3e, 5e, like that, where e is equal to charge of an electron, value is equal to 1.6 into 10 raised to minus 19 Coulomb. Okay. Now we will do one small numerical related to this one. What is the question here is, what is the total charge on 75 kg of electrons? Look like simple, but we will get a chance to apply two equations here. Okay. So we are going to find what is the total charge of 75 kg of electrons. So solution we start writing. So first thing is number of electrons in 75 kg, n is equal to, usually how we calculate n? Total mass divided by mass of one particle, right? So the same way, n is equal to total mass divided by mass of one electron. Here the total mass is given in SI unit, kilogram. So 75 kg. Mass of an electron, it will be given in the first page of the question paper, 9 into 10 raised to minus 31. Its exact value is 9.1 into 10 raised to minus 31. For simplicity, we use 9 into 10 raised to minus 31. So divide denominator 10 raised to minus 31 will be going to numerator, so plus 31 Okay, so n is equal to, after dividing 75 by 9, you will get 8.3 into 10 raised to plus 31. This many numbers of electrons are there in 75 kilogram of electron. Now actual question is, what is the total charge? So total charge quantization, just now we saw the property, right? Quantization Q is equal to total charge is equal to N into E. So N we have now, E also we have, because charge of an electron is 1.6 into 10 raised to minus 19. Recommended to use a minus along with 1.6 because charge of an electron is negative. Okay. So the answer is minus 13.3 into 10 raised to, you do the exponents addition. So then you will get that minus 13.3 into 10 raised to plus 12 after adjustment. Okay. So after adjustment, it can write in standard form. Standard form is minus 1.33 into 10 raised to total 13 will come. Since this is charge, the unit we can write Coulomb. Till now, okay? It's a numerical. You can expect 1 mark or 2 mark range. Now the famous part of this chapter, that is the Coulomb's law, that is force between 2 point charges. It is something similar to the Newton's gravitational law. You remember that one? Force between two masses is directly proportional to that. The similar way, this time it is the force between 2 point charges. It is how that force is, that is directly proportional to the product of their charges. Okay, if there are two charges Q1 Q2, then force between them is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So we will write the step by step now. You know that when we start a derivation, you start with simple steps. So if you want, you can draw one diagram also that represent this situation. Okay, because there are two charges, right? So better to write that first. Suppose 2 point charges Q1 and Q2 are, no need to follow as it is what I am writing here. You can write the way you understood this topic. Okay, I mean the statement. 2 point charges Q1 and Q2 are separated by a distance R. We can draw that one. So plus Q is the first charge. After some distance, we can mark another one plus Q. So Q1, Q2 we can mark. Separated by a distance R we can mark. Okay. Now we will follow the statement. What is the statement is? So before we go to the statement, we can mark the force between them. Because of both having positive charge, you can expect repulsion between them. That is the reason I marked F away from both charges. Okay. Because of both charges are having same sign. Now according to Coulomb's law, first statement is saying that the force F is directly proportional to the product of their charges. The charges are Q1, Q2. Yeah. Second one is force is inversely proportional to the square of the distance between them. So join them. F is proportional to Q1, Q2 by R square. So here some constant required. So F is equal to a constant into Q1, Q2 by R square. Here the constant of proportionality is 1 by 4 pi epsilon 0. Okay, there is a standard value for that. So in the calculation, you don't want to find each and everything, direct value you can apply. So F is equal to, we can replace this 1 by 4 pi epsilon 0 with a constant K. Okay, this is Coulomb's law, and epsilon 0 value also will be given in the question paper, 8.85 into 10 raised to minus 12. Okay, I hope this topic is easy. Coulomb's law, force between two charges. That is the statement actually. We will get a chance to apply for numerical later. Now, rarely asked this question, present Coulomb's law in vector form. Compared to the first statement, this is little bit mathematical touch is there. So we start now. Let the position vector of charge Q1 and Q2 be, we can mark the position vector for Q1 and Q2, okay, like vector R1 and vector R2 respectively. So you know, remember, yeah, last year grade 11 you studied this one, position vectors. Okay, we denote the force on Q1. This is the place we get confusion actually. we denote the force on Q1 due to Q2. Okay, force on Q1 due to Q2 by presenting like this one, capital letter F12. 12 stands for force on first by second. And the force on Q2, okay, force on Q2 due to Q1 by capital letter F21. If you read 2 times this one, your doubt will be cleared. Okay, so let me write F12 is equal to F21. Why it is same? Because they are equal and opposite forces actually. Okay, now we are going to do one drawing here, coordinate system. Okay, coordinate system, coordinate system, right? XYZ coordinate system we are marking. As we wrote first charge Q1 with a position vector from the origin, that is small letter r1. Put a vector symbol above that one. Okay, now the second charge, that is Q2 with a position vector from the origin, that is r2. Now we want to connect between them, so there will be a position vector between them also, right? So Q1 Q2 we connected now. Now see the arrow mark what I marked from Q2 to Q1 I marked, that is actually R21. Okay, and if you do the arrow mark from Q1 to Q2, that is small letter R12. Okay, just practice like that one. So the labeling we did. Next we want to mark the force, because both having the positive charge, direction will be away each other. So we mentioned before it, F12 and F21. F12 stand for force on first by second charge. F21 stand for force on second by first charge. Okay, so here if you look into the diagram and vector addition, you will understand that vector R1 plus vector R12 is equal to vector R2. Also you can write from there, vector R12 is equal to vector R2 minus vector R1. So left to right we can say like, through R1 we reach there. Now we go to other side. Also R2 plus R21, look into diagram and decide. R2 plus R21 is equal to R1. From there we can write what is R21, that is R1 minus R2. So we have expression same. You look into the diagram, same it is. The only difference is opposite sign will come. So from this R21 we can write vector R1 minus vector R2, and R12 we can write it is equal to actually minus R21. Okay, minus R21. So R21 is equal to minus R12 also you can say. Now we are going to write the magnitude. Maybe whoever taking mathematics, they remember how to write the unit vectors. Other students spend a little time with Google and understand how to write the unit vectors, okay, and the magnitude of vectors. So here I am going to write that one. The magnitude of vectors R12 and R21 is denoted by, you remember the magnitude, right? 2 line will be drawing on both side of the letter. So magnitude of R12 and the magnitude of R21, I am going to write below that one. Okay, magnitude of R12 and magnitude of R21 and their unit vectors going to write now. Just wait, writing is going a little slow. Okay, I am writing. So R12 is equal to R12 vector divided by modulus of R12, and that is the R12. R12 is R12 divided by modulus of R12, and R21 is equal to vector R21 divided by modulus of vector R21. Okay, so the force, actually our topic here is the force, right? So the force F12 can be given as F12 is equal to 1 by 4 pi epsilon 0 q1 q2. These things are same. The only difference happening is divided by that r square place modulus will be writing. So modulus of r21 square, then unit vector r21. Okay, the last thing read as unit vector. Okay, last thing read as unit vector. Now we can have one numerical related to Coulomb's force law. Okay, the question: 2 point charges plus 2 microcoulomb and plus 6 microcoulomb repel each other with a force of 12 Newton. This is the situation 1. Now if each is given an additional charge of minus 4 microcoulomb, what will be the new force? So this is like a current situation is given, then there is a change in the situation, then what is the new force? That is the question. So we can consider this like two cases. Case 1 is like plus 2 microcoulomb and plus 6 microcoulomb separated by some distance not mentioned here, but force between them current value is given. So I can write like case 1, first charge q1 is equal to plus 2 microcoulomb, q2 is equal to plus 6 microcoulomb, then and force is equal to 12 Newton. This much given, right? That is case 1. Now we can look into case 2. Case 2 meaning is what is the changes happened to first situation. So some charge added to the existing charge. How much added? Minus 4 microcoulomb. So the first charge will become plus 2 already there, minus 4 is equal to minus 2. Second charge plus 6 was there, added minus 4. So difference between 6 and minus 4 is plus 2. Okay. So here the case 2 we can write the q1 value. Actually we want to write q1 dash. Okay. q1 dash is equal to minus 2 microcoulomb and q2 dash is equal to plus 2 microcoulomb. And question is actually what is the force. So f dash is equal to question mark we can do. Okay. Okay, we start now. It is this type of situation usually handling by dividing the equation. It work fine. So divide the equation for both. So f dash by f, you can write f by f dash also, one extra step will come. Okay, f dash by f is equal to equation of f dash. Okay, so that is q1 dash q2 dash divided by q1 q2. Why I am not writing the distance between them square? Because situation remains same. Even I write q1 q2 by r square, that is going to cancel, and k if I am applying in both equation going to cancel. So actually we required only this quantity changes. So f dash by 12 is equal to minus 2 into 2 divided by 2 into 6 is equal to minus 4 divided by 12. So simplify it, so it will be minus 1 by 3. Now the time to cross multiply. So the new force between them will be f dash is equal to minus 12 into 1 divided by 3 is equal to minus 4 Newton. Simple question, right? This much only required. And because of the minus exists, you can understand one charge positive, one charge negative. Attractive force exists between them. Attractive force, if it is minus, you can decide attractive force exists between the charges. Okay, this is the numerical. One of the good numerical. You can expand this or extend this step. But right now for getting the 2 mark, this is more than enough. Okay, this was actually a board question. Okay, thank you.